All right, good morning, everybody, and thanks for joining us today. My name is Liam Casey, and I lead marketing at Dragon Q Energy. Today, I'll be moderating today's virtual open house. And yeah, once again, thank you all for being here. For anyone new to Dragon Q Energy, we're a Santa Barbara-based energy storage company developing one of the safest, most robust, and efficient battery packs in the world. But we'll get more into detail on that in a few minutes. Just a bit of housekeeping before we get started. We initially planned for a 45-minute session, but given the amount of ground we want to cover, it'll likely run closer to an hour. So my apologies for any scheduling conflicts there. And at the end of today's session, we'll open up a Q&A. You're welcome to add any questions that may arise in the chat as they come to mind, and we'll get to as many of those as possible as time allows. So, as for what we plan on covering today, we'll start with a look at our product roadmap, followed by a deeper dive into our key differentiators and learn more about what makes our technology fundamentally different from any other battery system on the market today. From there, we'll take a deeper look into our intellectual property strategy, the current technical and manufacturing readiness levels, along with some market insights. And then we'll get a closer look at an overview of the seed round before opening up for questions and discussion at the end. And for our team, I'm joined here today by Dan Casey, our CEO and founder, who leads the technical side and product development, along with Sean Casey, our Chief Commercial Officer, who oversees business and strategy, and finally, Philippe Pellerin, one of our early investors and board members. The good news for you guys today is that you only have to remember two last names. So, yeah, together we'll be tag teaming today's session, covering both the technical and business sides. With that, I'd like to hand over the word to Sean to walk through our product roadmap.
Awesome. Thanks so much, Liam. Yeah, this is definitely a family business, and I'm excited to be working with Dan and now my oldest son, Liam. Before we get started, first, welcome everybody. I'm really excited at the numbers we've got attending today and the level of interest. And what I'd like to do is just kind of really provide a framework of the market that we're operating in today and into the future. Of course, electrification is accelerating worldwide. This is driving record investment to meet exponentially increasing electricity demand across almost all sectors, with global consumption projected to more than double by 2060. In the US alone, battery capacity surged by more than 66% in 2024, with $110 billion slated for domestic battery deployment over the next 7 years. Dragon Q stands at the forefront of this historic transformation, driven of capital in human history. And this is the beginning of a global wave that will define the human condition for decades to come. So I know that sounds a little big and dramatic, but this is truly a transformative time for all of us, and it's pretty neat that we've got a small part to play in that. The fundamental human problem that we're solving here at Dragon Q Energy, if anybody's familiar with lithium-ion batteries, the next thing that comes to mind is the propensity for thermal runaway and potentially fire. We've solved this problem by forming a pressurized vessel. We draw a vacuum on that vessel and replace the oxygen with argon, which is an inert gas. And in combination of the vessel and the argon gas, we eliminate the conditions where fire can take place. And what this does is this results in a robust, safe, and efficient battery that can be put to work in any number of uses, which I'm going to cover here. Ultimately, our mission is to drive innovation by integrating safety, reliability, and efficiency into every product we make. So let's jump into our product line a little bit. On the left-hand side of the slide here, you'll see our 7.5 kilowatt battery. This is our go-to-market product. Primarily, it's a form factor that's easy to handle. We can move it around the shop. We can put it in the truck and bring it places. And most importantly, it's easy to deploy.
Sean.
To the right of that, you're going to see our power pole. This has the 7.5 kilowatt battery on the bottom, and in its installed state, the battery will be buried in the ground. Next to that is going to be our beacon. And just to show that we have a full stable of nerds here, Beacon stands for Battery Enabled Autonomous Cellular Off-Grid Node. And I think that's like a seven-letter acronym, which is pretty good. The Beacon differentiates from the power pole in that it's aimed at supporting more of telecom, edge computing, and off-grid edge compute functionality. And then, of course, we're moving into our more recently announced larger format 0.25 megawatt and half megawatt hour batteries that are going to be aimed more at data centers and grid management type applications. Our primary markets are going to be in the humanitarian, commercial lighting, military and government, telecom, and data sectors. These markets exist in any areas where real estate is constrained, it's hot, or we might also be looking at nearshore applications where our water resistance is required. So what this means is from expensive real estate in Hong Kong, New York, Singapore, Tokyo, to the most remote desert monitoring sites, from inaccessible mountain terrain to marine and nearshore operations, from keeping medication cool in an African tribal community to powering unmanned submarines, the application of DragonQ battery technology is limited only by the imagination. So that should give you a general overview of why we're here and what we're doing. And I'm going to hand it off to Dan here to talk about some of our key tech differentiators.
Thanks, Sean. That sounds pretty good. It's really compelling as we go into this transformation in the next several years, the next several decades. It's really, really exciting the work that we can do here. My name is Dan. I'm CEO and Chief Technology Officer of DragonQ Energy. To give you an idea of where my strengths lie, I could visualize and create very elegant engineering solutions. I can do that in my mind, and sometimes it happens in my sleep. I enjoy reading technical manuals for electronics components and all the things going into this battery pack. Okay, so by this nature, I'm an engineer. I spend a lot of time with my own thoughts. And so please just be patient with me as I share with you what DragonQ has created and what we're going to market here. So we'll get started. DragonQ Energy has invented a fundamental and very simple way to manufacture, scale, and install battery packs for energy storage systems, stationary storage. Really, anybody building a battery pack could even be electric vehicles. We do this with unprecedented levels of safety, efficiency, and it's all in a robust form factor. In this section, we're talking about differentiators, and one thing I'd like to point out is that me talking right now and the very few limited people on this call, we're some of the few people in the world right now talking about installing lithium-ion batteries underground. That's the basics. That's the premise. Sean covered some of the values around that as far as thermal efficiency and safety and other things. So that's our number one key differentiator. It's just simply putting batteries underground. And for those of you on this call who may not be battery experts, it might be a fair number of you. One thing I'd like to explain is that heat and the heat generation of batteries is the number one enemy to battery life. So it is every pack design, every EV design, every energy storage system design, they're all figuring out ways to efficiently mitigate and handle and keep the battery packs cool. It just so happens that we've found a very elegant, novel, low cost, and passive way to cool our battery packs. We're going on 2 seasons now of compiling and creating our own test data with battery packs underground. We feel really comfortable with our technological approach, and we have some very low cost ways to keep batteries safe and cool underground. And this makes us different and valuable in the marketplace. Uh, to accurately understand our differentiation, we also need to do a little shallow dive on what exists in the marketplace today. And what is currently being made, I look at what's currently being made on the market, simply three types of batteries. There's batteries being made that can go on a rack, and those are used in like IT situations, data centers, telecoms, rack mounted battery. A lot of people may have never seen those. However, I'm sure everyone on this call has heard of like a Tesla Powerwall. Powerwall type batteries is the second type of batteries that people are building. And a third, big energy storage systems, part of like commercial energy storage products that are on like several acres of property. You may have seen these. They're big white boxes, similar to ocean containers, big steel boxes. We call these ubiquitous white box energy storage solutions. That's a term that we've generated. So those are some current technologies and products that are available on the market today. However, there are it's the best that we have right now, but there is some problems. There's complicated engineering systems, which result in them becoming very expensive. They have shorter lifespan than the companies making them had originally intended. And here's a little nuance with these above ground systems that sit out in the sun. Right when the electricity grid needs resilient power during like a heat wave, everyone's running the air conditioning. Right when the grid needs power is when the efficiency and the output of these batteries go down because they're outside in a heat wave, they're being heated up by the sun. They need to run their air conditioner, their HVAC units, their coolers. All this takes away from the overall system efficiency. And it's actually being noted by the grid operators that the power they're expecting to see from the batteries and the energy storage they expect to see from these big systems is just not there. And one of the reasons is all going out in the cooling of these battery systems. So what DQE has to offer is a simpler, low-cost system. We've taken almost all the extra battery or all the parts out of the battery pack. There's not much more we could take out and still have a battery pack. And we've honed in on a system called cell to chassis, and that's something that overseas companies have been innovating on the last couple of years. And here's an example of top of one of our battery packs. And let's see if I can get it to come up here in our image. Yeah. So this is the structure, and we start building our battery packs right off the top of this. And so we start building the cells all the way on up, and you can see some of the pictures there in the presentation too. So we've truly achieved cell to chassis, which means all the other module and pack and rack and all the other components, they're all in a lot of the bus bar. We've taken a lot of that out of the picture. Another thing that makes us differentiated and how we can do what we can do is we have innovated and invented a bus bar technique to keep all the batteries working together in a proper fashion. We call that a parallel series parallel bus bar. So just by that long nerdy name, we can do three things with our bus bar. We can put all our cells in parallel. We can put those cells in series with the cells above or with the layer above it, and then we can put all those cells in parallel as well.
Dan,
Yep, sure, Philippe.
on that, because this is something that I've found kind of fascinating, is that by putting the cells in series the way that you just described with the proprietary bus bar that you've invented, it essentially makes the battery itself almost like a wire that can conduct power.
Oh, thanks.
Is
Thanks
that
for bringing
fair
that
to
up.
say?
Yeah.
Is that a big part of why the internal resistance is so low, which is what allows
Yeah.
less heat generation and allows passive cooling?
Yes, and that gets key to our IP. And I can cover a little bit further here. And if we want to do a deeper dive with any of the investors, we can certainly move towards like NDAs and have a longer conversation. But real simply, what Philippe is saying in a parallel fashion, we have a very thin bus bar. It's only 0.2 millimeters. And then in a series fashion, it's like we've got a 6-inch diameter wire in our pack, but it's only this thin. So we have really a low cost, low weight engineered solution to give us extremely low resistance to our battery pack. And that holds true for batteries, supercapacitors, everything. It's efficient and very powerful. Yeah, thanks for bringing that up. And our differentiator, because we're underground, we're thermal regulating to like an engineered earthwork right around the battery. It's not simply just soil, but there is like an aggregate gravel, and the passive cooling, simpler maintenance, and essentially a set it and forget it model. Our packs are so robust and maintenance free. They can be installed underground, monitored and supported, but essentially maintenance free. With this differentiated technical approach, we can do things that other battery pack manufacturers cannot do. And this opens up new market verticals that have not existed before. And in Sean's portion, and just earlier, he touched on near shore and port electrification. We were just at a Navy event at Port Hueneme Base here in Ventura. And I like these types of like customer input and feedback and customer discovery. They disclosed to us that they had purchased a Tesla Megapack system, which is one of these big white box solutions, and millions of dollars. And guess what? It got wet. There was a storm, there's some waves, some storm surge, and their $3 million system became a big paperweight. So they are very interested in our nearshore solution that is already hermetically sealed and can survive any sort of these storm surge events. Then again, downtown and city center locations, we can operate in those areas because real estate's constrained and there's just not a place for an acre or 3 or 4 acres to put a big, battery energy storage system, and you can't put these ubiquitous white boxes in parking garages. So with our system, it could just simply be buried under the sidewalk leading up to a skyscraper or in the landscaping. We could put megawatts of power in square feet underground and still use the surface for, like I said, landscaping, driving, parking, any number of things. And then one thing that Sean also touched on, we provide resilient power where it is hot. And we have, again, very novel and low-cost solutions to keep our batteries cool and safe underground. And that will be important in areas like India, Middle East, the southern USA. The list goes on. And to be honest, the planet is just getting warmer. I wish for the best, but fact of the matter is the planet is heating up. It is also hot in data centers, and we can provide a very, very easy solution for data center operators. As I wrap up this section, I'd like to point out that it's like a Guy Kawasaki concept. And if you guys aren't familiar with Guy Kawasaki, quick Google search. But he believes that value creation from a company comes from creating something new and novel, not just a little tweak or a little adjustment on a product. And we are squarely in that space where we've come up with something unique, innovative, and differentiated. And then what Sean touched on about the market size, we've got something differentiated going into one of the biggest markets that the world has ever seen. So that's a good spot for Dragon Q to be in. And it's a good transition point to talk about our intellectual property and how we plan to monetize our intellectual property. Well, thanks, Liam. IP is the competitive battlefield. Our patents and patents in general will determine the winners and losers in the battery competition in the coming years and next several decades. The DQE patent strategy is one of our core competencies and will be a key factor to our success. Simply put, we can refer to the slide here. We filed our provisional patent application in October of 2022. That gives us a disclosure on the technology around 2 fronts, around the safe containerized approach, and around the powerful and efficient bus bar that we've created. And I'll expand on these a little bit further as well. A year after our priority date and our disclosure date, we did file our patent treaty country application. And what that tells the world is that we would like to receive intellectual property protection in foreign countries. Now, even though we just filed that application, in general terms, we had about 18 months to file and select the countries we would like to receive protection in. And that filing was done just this past May in 2025. And we enter the national phase for US. Actually, we had to specify that. EU, Korea, Japan, China, and India. And it's been determined by the DQE team and our IP attorney that those were the best countries as far as battery innovations and licensing and protection. So let's talk about the two technological tracks that DragonQ Energy is proceeding on with our intellectual property. Now, this far in the call, and if you've reviewed our information and read our decks and other things, one technological track is around the safety containerized approach. And this gives us unprecedented thermal runaway mitigation, control, and relief. And we can do things controlling thermal runaway that just other battery pack manufacturers cannot do. And it also gives us an efficient and simplified thermal management controls. I should point out too that these features in both these technological tracks are of interest to all battery pack manufacturers. In general terms, we won't be a solution for everyone, but it's our job as we activate licensees to identify companies, technologies that can use this intellectual property. All right, second track is the powerful and efficient simplified battery pack architecture, the Parallel Series parallel bus bar. And again, it's not just for our 7.5 kWh pack, it's for megawatt size packs, it's for smaller size batteries, it's for supercapacitors. Our intellectual property really takes a big rap of cell chemistry, cell systems, battery systems, and really anything with a cell, whether it's cylindrical, prismatic, or a pouch cell, we can apply our intellectual property to that. We plan to monetize our IP with a mixed approach of paid R&D, opportunistic manufacturing, and I actually just wanted to jump in there when Sean was talking earlier. We selected the 7.5 kWh battery at 48 volts as something that we could afford to prototype, build, and bring to market, and it represented the right voltage range for telecoms, a lot of industries, maritime, a lot of things, and it was a suitable capacity to do a certain amount of work. And quite honestly, it's what we could afford to build and bring to market, and now it's finding a lot of market traction. So that's really good. We plan to build the licensee opportunities through business development relationships with key partners. And as Sean talked about earlier, this is all limited by our imagination and how we plan to activate licensees and find product market fit. One example is our relationship with Spitzer Lighting. That's been a very good relationship. They've been one of the first few companies that saw value in burying the battery and attaching a light pole to it. And it's a very very simplified approach, but no one else's battery packs could do that. Now, the 7.5 kWh pack that we're getting certified and going to market with, it's good as like power for like a highway light pole or a city street light pole. However, my friend Howard, product developer there at Spitzer, we were sitting here in this meeting room, and he said, I need a 12-volt version of that that's 1 foot tall, and I need it to be $1,000 for sidewalk bollards. And a sidewalk boulder is just like maybe a 3 foot tall light pole that you would see in like a landscape environment. And then he said, I also need a 24-inch or a 2 foot tall version that costs $2,000, and we need that to be 24 volts, and that will be for parking lot lighting and parking lot light poles. And we talked a little bit about the market size and the proliferation of other people that are also making solar bollards and solar street lights. And we put numbers in the 50,000 unit range, 50,000 units per year. And that does represent like a smaller form factor. And then later in this talk, we'll also talk about larger form factor, instead of going down in voltage and down in capacity, going up in voltage and up in capacity to more expensive and lower volume units. You can be rest assured, Dragon Q Energy team is keeping a focus on global trends and particularly what's happening in Asian markets. The most stringent safety and regulatory and policy initiatives are coming out of China, Korea, and Japan, with a very tough standard recently being introduced. And I don't see it on there, but it doesn't matter. It's GB 38031. It's a long number. Doesn't matter what it says, but this new standard for battery packs coming from overseas requires that smoke and fire stay on board or inside the battery pack for up to 2 hours. So if the battery is installed in an electrical vehicle, the occupants and passengers of the vehicle can exit and get out. Now, generally speaking, no one else has a battery pack that can come anywhere close to achieving this type of standard. And this will be of very high interest to automotive OEMs. I can't quite name a few yet, but we are talking with some. But then also big battery manufacturers like BYD and CATL. They're all about wrapping licensing and patents IP all around this. These are just a few examples of what will allow Dragon Q Energy to thrive through tough market challenges. And then this will also be the type of strategy that will allow us to seize future business opportunities. As I wrap up this part on IP, I'd like to shift now to talking about our technical and manufacturing readiness. Liam, if you could switch over the slide.
Yep.
Thanks so much. I'm just gonna get a little drink here too. And I promise, I think this is my last section, but this is all good stuff. We really enjoy building these things, and
You're doing great.
thank you. And quite honestly, I just feel honored that I get to come to work every day and build the coolest battery tech that is being made. And we're very humble, but we also know we're making good stuff. All right. Technical readiness level. That just describes our maturity of our technology, getting ready to go towards market. So if we refer to the chart, we still do need funds, and that's why we're raising seed funds. We still need funds to raise our modest-sized go-to-market battery pack from a 8 to a 9. We're at a 9. That's a product that's technically ready to go to the market. And behind that, we need to do the engineering work of the power pole and the beacon to get those units ready to go to market as well. And then you can see trailing behind here are the concepts. Here on the lower left is the, I'd really just blanket that as the data center product line of product. And in that line would be 48-volt massive batteries and 400 and 800-volt batteries. And also the similar line would be 400 and 800-volt supercapacitors and 48-volt supercapacitors used in different parts of the data center. So that's where we stand at technical readiness level, and seed funds will, push the power pole and the megawatt or 7.5 kilowatt battery pack. That'll push that to a go to market level, and it'll move the data center products up to like a TRL 6 or 7. Before we go to the
Dan, if I could just jump in real quick.
Sure.
Our stated goal in the investor brief is the seed round funds will last us approximately 18 months, so into spring of 2027, and we will be well to market with the 7.5 kilowatt battery and advancing both the 0.25 and 0.5 megawatt batteries about to around where the 7.5 megawatt is now. So we'll be at the end of our seed round run. We are aiming to have the larger format batteries queued up and ready to go to market ahead of a Series A.
Yeah, thanks, Sean. And that's something that over the last money we'll be raising here. Before we switch slides, I'll just touch on certifications and where we stand with certifications for our battery packs. We are currently in the middle of UN 38.3, and that is a certification so these battery packs can be safely transported. And then we are in the middle of UL 1973 for standalone energy storage. That's just for safe use by a customer, and so that they know they're getting a safe product. It helps permitting desks stamp plans because they know that it has a UL certification. And then also IEC for thermal runaway, and the battery pack is in the middle of being evaluated for its thermal runaway characteristics. We have not begun testing on UL 9540 or 9540B yet. However, we will be embarking on that, and that will be a key use of funds out of this seed raise. And what those certifications will get us, let's start with 9540 just blank, is will give us and the customer an understanding of the characteristics of a whole energy storage system. That includes solar, the inverters, all the electronics that go into making an energy storage system complete. That'll be 9540. And then 9540B actually is like a stringent, it's not actually a certification, but it's actually more of a report of how your battery behaves, or how our battery behaves under thermal runaway conditions. And we're actually looking forward to our 9540B report, because we could have one of the most compelling reports there is, where we keep thermal runaway on board. We have stepwise release and venting of gases, and a more intelligent approach to this than just letting it burn. I think that's the most modern strategy for a battery fire, is just to let it burn out. We don't prescribe by that. But just quick note for battery nerds, our containerized approach in our 9540B report could also unlock NMC chemistry for 9540, a good 9540 report. And if anybody wants to know more about that, it actually opens up about half of the battery industry for 9540. And it's something we can expand on. I guess we can just move in beyond that. Let's see. So that covers certifications and technical readiness. And Liam, can you switch over to manufacturing readiness?
Yeah, sure.
Readiness, thanks. Yep. Just like the previous slide, our MRL, or manufacturing readiness, assesses our readiness to manufacture. And we have taken a very intelligent approach to taking the risk out of setting up manufacturing lines. And we've done that by, as we're doing our engineering and going to our certification, we're also tilting up contract manufacturers. So we do have contract manufacturers that can build our, let me rephrase that. They are in the process of learning how to build our battery containers, our poles, and our battery packs. And as you can see, again, the MRL for the battery packs and power pole and beacon is quite a bit further along. And I think this graph was made, a month or two ago. So our MRL for the battery pack is probably at an 8 or a 9 right now, and with contract manufacturing, we're going to get to a MRL of 10 very quickly. And with use of funds from the seed raise, we also push the manufacturing readiness of the data center products, of the bigger batteries, and then let's not forget the licensing opportunities with Spitzer Lighting and the smaller battery packs as well. Before we switch away from this slide, I would just like to touch on some competencies of the company, and they're not necessarily in the slide, but there's some things that we have gotten very good at. One thing that we've gotten good at is staying in our lane. We have learned, like most businesses learn, what our reproducible trick is. And not that we're trying to trick anybody, but we've just learned what we can do over and over again and rinse and repeat. And that lies around the containerized safety approach and how to apply it to other battery packs, and how to recognize the use of our parallel series bus bar with other battery form factors. And one example of that would be we've been in a lot of discussions with Porsche, and we're starting to shape up some non-compete and paperwork and other things to get into some more detailed conversations with Porsche. And we've actually been brought to Porsche and Volkswagen by different people, but the partnership and the outcome hopefully will be the same. But Porsche Group and Volkswagen makes a unified battery cell. It's their way to like make a standardized battery cell for their whole product line. And of course, with one of my strengths being visualizing, conceptualizing these engineered systems, of course, I see a way to use our IP to use their unified cell to make cell to chassis possible with Volkswagen. So that's something exciting. And as a competency, as our rinse and repeat and do it over and over again, those are the types of things and those unintended side effects of things that come up. And that's what one of the most exciting things about our job is, the stuff that just comes out of the woodwork. And it's like, oh, hey, make a battery pack like this. That would be incredibly valuable. It's like, okay, let's talk about licensing that and figure out who's going to manufacture it. All right, another competency is conceptualizing from the catbird seat. And what I mean by that is, from what we've innovated and from what we've invented, here's what innovation looks like, and here's what the future looks like from our seat. It's really exciting. From where we're sitting, the future looks different from where everybody else is sitting. Another strong point is strong R&D and fast initial prototyping. We've got phenomenal and very intelligent engineers ready to build and take risks, and they're not worried about getting fired or anything like that. And we can R&D and prototype very quickly. And then we're also strong at creating business development interests with our partners and moving those to licensing opportunities and activating licensees. Beyond competencies, we have some core capabilities, some things very unique to domestic US manufacturers is we have a full pilot assembly line. It might not look like an assembly line. It looks like benches in different parts of our shop, but we have all the components, all the equipment, all the trained staff for cell grading, cell quality control, pack assembly, pack welding, pack testing, pack quality control, destructive testing. I think you get my point. And our engineers are chomping at the bit for automated robots to build battery packs. And I freaking love that too. I really want to see that in our shop. And not just for the cool part of having cool robots build batteries for us, but because we've built a team with the competencies that can actually commission those robotic lines. And that's really exciting. So to kind of wrap up on that high note, we can shift now to Sean, and he would like to talk about our current go-to-market and some product market fit. Sean, you want to take it away?
Yeah, sure, Dan. Awesome. Let's see here. I think before I start, generally what I'm going to be talking about here is traction in the market. We kind of touched on the larger trend of electrification. I think it's clear about how we're going to fit into that larger trend. But just from a personal note, and as a seasoned entrepreneur, I've never had the opportunity to participate in a market where almost everybody that we talk to is as excited or perhaps more excited about the implications of our product for them as we are. It's almost all green lights from almost anybody that we talk to, many of whom are listed at the bottom of the slide here. But so before I kind of get into that, I'd really like to talk about um, traction in the market, where we're at now, and what we've been able to accomplish with our shoestring budget. Right now, we are in the process of deploying or about to deploy an 8-unit pilot program through our nonprofit partner, Unite to Light. These are going to be deployed throughout Santa Barbara, and they include a tsunami warning system. So this is a backup power source for tidal waves that might hit the shore of California near Santa Barbara. They're powering 2 research monitors. University of Santa Barbara has some land grants that they're conducting various research on, and these 2 power poles will relay sensor data through 5G cell networks back to the university. And on a little bit more human scale, they've also deployed one of these to provide light internet access to a safe parking location in Santa Barbara where people are living in their cars, and they now have light and access to Wi-Fi for their phones if they need it. Let's see here. Dan mentioned Spitzer Lighting. For those of you who are not familiar with Spitzer, they're one of the largest commercial lighting manufacturers in the world. Chances are, if you're buying something at Home Depot, it was made by Spitzer.
Your parent company, Sean.
Oh yeah, Spitzer Electric. Yeah, sorry about that.
Alpha
Yes.
LED, other parent company.
Yes. So to kind of put this in perspective, we are having a conversation with one of the largest lighting manufacturers in the world about producing battery powered bollards and sidewalk light, street lighting at the units of 50,000 each. Now, just some back of the napkin math, that's almost $10 million in licensing and royalty revenues right out of the envelope, first out of the gate. This is not done. The ink's not dry. It's not finalized, but this is just, one of a dozen of these types of conversations that we're participating in and gaining traction in. Another one of these is a T6. This is a military version of the automotive battery. The government has issued what's called a SBIR, and this is a Small Business Innovation and Research Grant, where they want to reduce the thermal runaway of their current T6 military batteries to smoke only, without changing the form factor, without changing the chemistry, without changing the architecture of the battery. And, as Dan has illustrated, our pressurized vessel IP fits right in there. And then if we look at the projection of those T6 batteries, the U.S. military buys 180,000 of those every year, with projections of those to scale up to 1.2 million each by 2030. And then incidentally, that T6 battery is also a NATO battery. So all of our allies also utilize that battery and could potentially adopt that, our technology, into a final solution there. Let's see here. I think that about kind of covers it. I just wanted to give a brief overview of our traction. I think, Dan, did you want to jump in with, you're more familiar with some of the larger format traction that we're getting.
Yeah, one of the things that excites us most is the unintended side effects, and I kind of touched on that before. But one thing that's come out of the woodwork is a potential joint venture, something we're shaping up as we speak. Joint venture with a supercapacitor manufacturer, a microgrid manufacturer, a private equity firm, and we're getting a green light to build a prototype of a 48-volt DC supercapacitor with 1 megawatt of power. And just to put it in simple terms, supercapacitors are like the sprinters, the Usain Bolts, the 10 to 12 seconds of power. Well, in data center terms, it's actually half a second to 1 second. That's what they use supercapacitors for. So it's the sprint. And then the battery is more of the 1 minute to several hours or several minutes or several hours of power. We've actually gotten a green light. We're starting to develop a prototype supercapacitor that's 8 inches in diameter and about 3 meters long. And I've just been using the word sinister, man. This supercapacitor is just so powerful. And this is the prototype. And the prototype can put out 1 megawatt of power for not 0.5 to 1 second, but for 30 seconds. And the calls we've been on with data center engineers, we have a supercapacitor that can do that. We can simplify data center systems and take certain things out because we've got a supercapacitor that runs for so long. And where that will go is ultimately to a larger system-wide or a facility-wide supercapacitor for the whole facility. And then as data centers are moving towards 400 volts and 800 volts DC for distribution energy. And then one exciting thing that's coming out of this joint venture partnership is one of the private equity firms is signing a MOU for a 2.5 gigawatt data center in Alaska. And our supercapacitors and large format batteries are being considered at the design phase and planning phase. And it's going to be in the quantity of hundreds of large format, expensive battery packs and supercapacitors. And the point we're trying to get across is these are like initial projects. These are initial relationships, and we don't see any of these slowing down as data center proliferation increases. These types of unintended side effects and product market fit, these are just going to continue to accelerate for us. So yeah, Sean, thanks for letting me jump in there.
Oh, absolutely. Absolutely. Liam, do we want to switch over to the next slide here? Awesome. Okay, this is we're going to start talking about money here. So hopefully everybody will stay on the call for this. But before I get started on our current seed round and our current raise, I really would like to take a moment to highlight how extraordinarily far we've been able to advance this technology and programming on what really amounts to a shoestring budget. Before this raise, we through Dan's initial contributions in a friend and family round and a pre-seed round, we've raised about $850,000 over the last 2 years, which, if you look at what we've accomplished with that, it's really remarkable to me. And I just want to stress that we're asking for a bigger shoelace, but we're still going to be running this on a budget conscious, cost effective manner. So what we've been able to achieve with our funds so far is going to be our prototype unit, our 3 MVP, those are minimum viable product units. And we've been able to deploy our 8 pilot units through our pilot program with Unite to Light. We've also been able to get in place significant protections for our patents and intellectual properties and really get that general framework and overall strategy established. So as we move into the next round, we're going to continue to fortify our position from an intellectual property, trademark, and trade secret and patent standpoint. But again, kind of touching on the most exciting thing for me that we've been able to achieve is just this this unparalleled traction in the marketplace. Um, the just the speed with this is getting picked up by and every phone call and email that we're getting with new inquiries is just really astounding to me. So with that, I'm going to pivot over to our current ask. We're during the seed round, we're raising $4 million. This is being done through Safe Agreements. Incidentally, as of this morning, I have just shy of $700,000 of written safe agreements out that we're waiting on wire transfers from. So we're a little less than a quarter of the way there, but I'm really happy with that, given that we're only a couple of weeks in. Um, how are we going to put this capital to work? That's what everybody wants to know. As Dan has indicated, we are space constrained. Dan's working out of a 1,500 square foot or less kind of contractor's garage off the UCSB campus right now, and it's really elbows to elbows in there. And we need a larger kind of more purpose-built space. We do have several locations that we're evaluating for that will fit our budget and space requirements. Of course, as you're seeing, everything is kind of relying on Dan or I or Philippe or Liam. We've got a pretty small stable of talent right now, and everybody's got to handle everything that we need to do. So hiring some key executive and leadership roles, and also bringing on board some of our first operational leaders are going to be one of the main things that we're committing funds to. As Dan already covered, additional technology validation and certification, expansion of our IP, trade secret protections, and initial licensing are going to be really lay the groundwork for our go to market with the 7.5 kilowatt battery, and then bring along the technical readiness and manufacturing readiness level of the 0.25 and other megawatt units and supercapacitors. So that really kind of represents everything that we're trying to do in a nutshell. We do have a small contingency there of 10% just for rainy day, but so far I'm pretty happy and impressed with how fiscally responsible we've been managing this organization. Again, Dan and I are both seasoned entrepreneurs. We started a business together about 15 years ago that I stepped in and took over. That sold last year, and Dan is, and I'm now really excited to have the opportunity to work with Dan and partner with Dan again. That's really excited about that. So that concludes what I have to say. Liam, I don't know if you want to pick it up from here.
Yeah, sure.
Awesome.
So yeah, that wraps it up from our side for today, and we'd like to open up the floor to you guys for any questions which you guys may have. And yeah, to keep things running smoothly, we just asked that if you could add the questions to the chat, that would be great. And we'll go through them in the order which they come and try our best to get as many as we can as time allows. And just while the questions start coming in, I can get started with one of our frequently asked questions, which is, how do the current tariffs with China impact DragonQ Energy, and how do we mitigate these developments? And yeah, I think my dad has a good knowledge on that one.
Oh yeah, I'll take that one. Yeah, we actually have gotten that one a lot. It's a great question. Really, the answer is quite simple. The advantages of Chinese cell manufacturing, despite the tariffs, the benefits of the Chinese cell manufacturing still outweigh the tariffs. From a cost standpoint, we cannot buy a higher quality cell that is U.S. made for anything even remotely close to the cost of the Chinese cell. So, unfortunately, that requires that we're going to be manufacturing in China. From a tariff standpoint, what that means is we are not going to want to onshore any of our finished products back to the U.S. as we might have under different circumstances, but rather we're going to distribute direct to consumer, or direct, wherever those sales are made, direct from China. So our goal is to avoid the tariffs to the great to the highest degree possible by not bringing finished product back to the U.S. unless it's selling in the U.S.
Yeah,
market.
that's a good point, Sean. A lot of our power poles will go right from China to Africa as well. We won't even touch the U.S. soil. Yep. Uh, Liam, do you want to? It looks like Bob threw up a question there in the chat, and that might be something Sean can tackle.
Yeah, sure. Bob asks, what is your path/timeline to achieve 100% TAA compliance?
I'm not sure I'm not sure what TAA is. Bob, could you expand on that?
Yeah, we might need to come back to that too, but it's basically products sold to the U.S. government. Um,
Oh,
Yeah.
yes. I'm sorry. Yeah, and Dan's probably going to be better off to answer that one.
yeah, right on the spot. We might break out, and that might be something we talk about at our visit, Bob. But if
Yes, that's a hard question. We talked about this before, Dan, and I mean, I know there's a couple of dependencies there, and so that's it's maybe an if-then kind of a proposition.
Yeah, well, to make you look good, we do have that relationship queued up with US BESS, and we are really interested in working with them on their battery management systems that they're making in the US, because even our battery management system chip that we bought and selected from a European chip manufacturer or chip company, let's say, the chip is origined in China. So yeah, working with some of the partners that you brought to us, and oh God, even this US company called Amprius to make these really exceptional silicone anode cells. I really want to use them in our battery packs, but guess what? They're manufactured in China. So yeah, maybe not the straightforward answer you were looking for, but we're working on it.
Yeah. Well, we have some options, as far as non-US and non-China manufacturers through Korea, i.e. Samsung.
Yep.
There's some other ways to skin that cat rather than just purely US made battery.
We have a drop-in cell replacement from Samsung. It's a E36 cell for a battery pack. So that's one thing, and we're actually having packs evaluated with those cells in, so the certification can go smoothly.
Yeah. And the good news is our architecture is cell agnostic, so we can, as Dan said, drop in, almost any type of off-the-shelf cell, and with some minor adjustments, deliver superior performance.
Yep.
Hey, Philippe, I see you got your hand raised. Do you want to jump in real quick?
Yeah, if we're done with that topic, I don't want to cut it off. That's why I kind of brought my hand back down. So if there was anything else on the TAA.
I just have one thought on our scaling up our pilot assembly lines for US manufacturing of battery packs. If that's of interest to a customer, i.e. US government, then there's funding and grants and other things to help us ramp up that type of domestic assembly line. We're happy to do that as well. But the customer demand has to be there for the US made product.
Completely understand. No, thank you for help. I'm sorry for throwing out, a multi-layered question there.
Yeah, acronyms and stuff. Yeah, no problem, Bob. Yeah, thanks.
Yeah, I just wanted to clarify one thing. So to achieve the technical readiness level 9 and manufacturing readiness level 10, what's our expected timeline to achieve that?
For the 7.5 kilowatt hour pack, it's
Correct.
It's a very short timeline for technical readiness. It's basically certifications and the UL.
The ones that are in process.
Yeah, that are in process. And on those, I'd put a timeline of 8 to 12 weeks. It's a short timeline. Yeah, in progress
And
on
then
those.
for manufacturing, you were saying that we were probably a little farther ahead than what we were showing on the.
Well, not quite, because like I said, we're de-risking our manufacturing tilt up with using contract manufacturing, and Busan, our contract manufacturing partners, they've been very close to this all along. And as we've been doing our in-house R&D and engineering, we've been sending designs and sending things out for contract manufacturing readiness, and they're ready to build upwards of 100,000 packs a year for us. Those are the types of volumes they can build in.
Great.
Yeah. Anybody got any further questions? All right. Then, before we close today, I just wanted to say thank you to everyone who was able to join us today and learn more about DragonQ Energy's safe, robust, and efficient technology. If you'd like to continue the conversation with us or learn more about the next steps in making investment, you can scan this QR code up on your screen here, which will take you directly to a link for a 30-minute call with Sean. And this would be a great opportunity to ask any deeper questions about the round, explore your fit, or discuss the process in a bit more detail. And yeah, once again, thanks for your time today, and we are looking forward to speaking with you guys soon.
Thanks, everybody. Thanks, Liam.
Great job,
Thanks.
everyone.